given 2 or 3 functions, we're going to do g plus f. G plus f means that we're just going to add the 2 functions together. It's not giving us a value to plug in. It just says x. So we're just adding the 2 functions together. So g is x squared plus 1. And then we're adding f onto that, which is 2x cubed. That really just means you're combining like terms. There aren't any like terms, so let's just rewrite it in order. 2x cubed plus x squared plus 1. Done. G times h for the next one means exactly that. You write out g, you write out h, and then you have to multiply them, which means you have to FOIL or distribute, whatever you want to call it. So 2x cubed minus 3x squared plus 2x minus 3. There's no like term, so that's it. F of g means we're plugging g into f. So we're going to take g, x squared plus 1, and insert that into f, where the x was. So that's 2 parentheses x squared plus 1 cubed. So officially, since that's cubed, you would have to multiply that all the way out, which means you have to do x squared plus 1 times x squared plus 1 times x squared plus 1, and then multiply everything by 2. I don't want to do that, so I'm not going to. I do know that it would be 2x to the 6th, and it's going to end with a 2, but I don't want to do the other stuff. Be 6x to the 4th plus 6x squared plus 2. There it is. G of h. This time we're plugging h into g. So we're plugging h, 2x minus 3, into g. So instead of x, we have 2x minus 3 squared plus 1. Squared I will do. That's 2x minus 3 times 2x minus 3. So you multiply out 2x minus 3 times 2x minus 3, you get 4x squared minus 12x plus 9 plus 1. Combine like terms, get plus 10. All right, number 8. Find the domain. So for the functions that we've looked at a lot of polynomial functions like a and b. We've also looked at rational functions like c, square root functions, radical functions like d. So for domain, polynomial functions like a and b, the domain is always negative infinity to positive infinity. There's no restriction. That's a line. There's no restriction on a line. B is a parabola. There's no domain restrictions on parabolas either. Negative infinity, positive infinity. 1 over x squared plus 3x minus 4, that rational function, there's a restriction because you are not allowed to divide by 0. So take that denominator, set it equal to 0, solve it out. So you could factor that. So you would get x plus 4, x minus 1. So we get x equals -4 and x equals 1. Those are the values that we're not allowed to get because that would make the denominator be 0. So I'm going to picture this on a number line. -4 and 1, those both would get open circles. You have to remove those points, which that tells us that we've got 3 intervals here. -infinity to -4, and then -4 to 1, and then 1 to infinity. 3 separate intervals there. This last one, the radicand, the stuff inside the square root, 6x minus 30. You're not allowed to have negatives in there. So it has to be greater than or equal to 0. If you had a negative, it would be imaginary. Then solve that inequality. So add the 30, divide by 6, you get greater than or equal to 5. Which is including the 5 and going to the right. Which means 5 to infinity, and it's a bracket at the 5. -x cubed plus 2. To graph that. First of all, it's an x cubed function, which you should know looks kind of like that. It is a negative x cubed function. The negative is going to reflect it. So instead of going up and to the right, it actually is going to reflect and go like that. And then the plus 2 shifts the entire graph up 2. So up 2, that's our new origin. And then the parent function points that you need to know from x cubed are that it's always 1 away. Because like 1 cubed is 1. But this time, remember, it's going in this shape. So it goes this way instead. 1 cubed is 1. 2 cubed is 8. So we go down 8. 1, 2, 3, 4, 8. And it would go the same pattern on the left. 1 away and 1. 2 and 8. 8 puts you at the 10. So there's your x cubed. Something like that. Now, F inverse for part B. You switch your x and y's, you solve for y. So we're going to call that x equals -y cubed plus 2. Switch x and y. Now we're going to solve for y. Subtract the 2 over. We've got a negative there, so we want to divide everything by negative, change all those signs. And then to get rid of the cube, we're going to do the cube root. We get y equals the cube root of -x plus 2, or however you want to call that. So we need to graph that. When you graph this, you might know that the cube root function looks like that. It's like a sideways x cubed function. Since it's a negative on the x, it actually will be going the other way. It's kind of like that. And then when you're figuring out the shift with a problem like this, you have to be really careful because the best thing to do is factor out that negative. Because this is actually going to shift 2 spaces to the right. And then it's going to be reflected. So if you shift it 2 spaces to the right, that's your new origin. And it's going to have this shape to it. So cube root of 1 is 1, but it's got to be going down this way. Cube root of 8 will be 2, going down that way. Cube root of 1 is 1. Cube root of 8, 2. Close. Now, another thing that you can keep in mind about these, since they're inverses, that means the x and the y's are switched. They should be. So when we switch, let's pick a point here, like negative 210. That point right there is negative 210. If you switch the x and the y, it means you should get a coordinate on the inverse at 10, negative 2. 10, negative, that's exactly what we did. So it's a good way to check it if you had to graph them both. When you flip 1, 1, you still get 1, 1. So that's why that point didn't really go well. That's why they both have 1, 1 there. All of your coordinates would just change. The x and the y's changed. Kind of a tough question. So this is called the difference quotient. When you're going through and doing the difference quotient, the first thing you do is you plug in x plus h into the function. Since there's x's in 2 spots, both of those spots get x plus h. So it's x plus h minus 2, and then x plus h squared. That's the first step. And then minus g of x, it's minus just the original function. Make sure you put it in parentheses. And that's all over h. You need to multiply it out, FOIL it, distribute it, combine like terms, do all the algebra steps. So when you multiply out x plus h squared, you get x squared plus 2xh plus h squared times that negative 2 right there. So x plus h minus 2x squared minus 2 times 2 is negative 4. xh, negative 2 times h squared. We also have to distribute this negative blue portion. Negative x plus 2x squared. All over h. So now we combine like terms. And there's a good check right here that if there's no h in the term, it should cancel. It should have its opposite up there, like x and negative x. Like negative 2x squared and positive 2x squared. The remaining terms all should have an h. From those remaining terms, we're going to factor out the h because they all have an h. So factor out an h, you get 1, you get minus 4x, and you get minus 2h. Remember, that's all over h. Since there's an h factored out with the h in the denominator, you can cancel them. So we're left with just 1 minus 4x minus 2h. But then since we had an h in the denominator, you can't have zeros in the denominator, so make sure you mention h is not allowed to be 0. Find the inverse of each function. So to find the inverse, you switch x and y and solve for y. So this would turn to x equals 4y minus 8. and we're going to solve for y. So you add the 8 over. Divide everything by 4. And you get y, or you could say f inverse of x equals x over 4. 8 over 4 is 2. There's your inverse. And it says identify the domain and range of each. This is still a line. X over 4 is like 1/4 x plus 2. So since this is a line, that means your domain is negative infinity to positive infinity, because lines go forever to the left and forever to the right. Also, this is a line with a positive slope, which means it goes down forever and up forever. So it's negative infinity to positive infinity for the range as well. For B, same thing, switch x's and y's. So x equals 2y plus 3 over y plus 4. And we're going to try to solve for y. So we can say it's x over 1, so you can cross multiply. Distribute. And now we're trying to solve for y, so we need to get everything that has a y onto the left side and everything else to the right side. So this would be xy minus 2y equals 3, and then move the 4x over there. So everything with y is on the left. Factor out y. Which means our equation, when you divide to get y by itself, you get 3 minus 4x over x minus 2. And we'll get the domain and range from that. Okay, your domain is everything except 2, because a 2 would make the denominator be 0. 2 would make the denominator be 0. X minus 2 equals 0, you get x equals 2. So domain's negative infinity to 2, union 2 to infinity. Everything but 2. Your range, I've mentioned this in other problems, you can get from the coefficients of x, the negative 4 and the 1. Negative 4 over 1 is negative 4. So it's negative infinity to negative 4, union negative 4 to infinity. Now, the other thing about domain and range with inverses, if you compared it to the original function, this domain would be everything but negative 4. It would be negative infinity to negative 4 and negative 4 to infinity from the original function, because the domain and range will switch. If your domain was negative infinity to negative 4 to infinity, that's going to be the range of the inverse, because the domain and range switch. Graph a piecewise function. My first step is to draw vertical lines where it changes from one function to another. I'll use a highlighter. So it's going to change at 0, and it's going to change at 3. We got a vertical line at x equals 0, and a vertical line at x equals 3. That's where the graph changes from one piece to the other. So on the left side, less than or equal to 0, we're graphing x squared minus 1. X squared minus 1 is the parabola shifted down 1. So if it's shifted down 1, also notice that it's an or equal to, so that means on the boundary we're going to put a filled in point. X squared minus 1 means shifted down 1, filled in point because we're on the boundary right there. And it's the parabola x squared, which you know goes 1, 1, 2 away, up 4, 3 away, up 9. And it's just that parabola, or half of a parabola. In between, we're graphing absolute value of x minus 2, which is the absolute value function, which is a v, shifted to the right 2 spaces. So that means that the point of the v is shifted to the right 2 spaces. And then it makes the v, goes up 1 over 1. As we're doing that, you got to notice that on our left boundary, it's going to be an open circle, and on the right boundary, it'll be a closed circle. So on the right boundary, it's a closed circle. Left boundary, it's an open circle at 2. But it's the v shifted to the right 2 spots. Now, if you would rather not graph this way, if you just want to plug in points, you can plug in points. Plug in 0. Plug in 0 here. You get 0 minus 2. Absolute value is 2. So that's why it's an open circle up there. Plug in the other boundary. Plug in 3. 3 minus 2 is 1. Absolute value is 1. That's why it's at 1. You can just plug in points. The last graph is just 2. Flat line, 2. Open circle at the boundary though. So here's 2. Open circle at the boundary, going to the right. So here's another piecewise function. But we don't need to graph it, we just need to answer questions. We're plugging in -2. We don't need to graph it, we can just plug them in. You just have to identify where you're plugging it in. Since it's -2, -2 is less than 3, so we plug it into the top piece. So that's 2 times -2 minus 3, then -7. F of 3. Neither of these allow you to plug in 3, because neither of them say or equal to. Neither one of them. So there is no value. There's no defined value. It's undefined. Because you're not allowed to plug it into either equation. If one of them had the or equal to, you would plug it into that one. But it doesn't have the, if it doesn't have it, you can't plug it in anywhere. And plugging in 7, 7's definitely bigger than 3, so we're plugging into the bottom. 7 squared plus 5, 49, 54. G of f of x means we're plugging first into f, then the answer gets plugged into G. So the first thing we do is we start with the domain of F. I find the domain of F. Inside the square root, 2x minus 6 has to be greater than or equal to 0. So you get 2x greater than or equal to 6. X has to be greater than or equal to 3. We're going to do the same thing, same idea with G. Our restriction on G is you cannot have a 0 in the denominator. So it's like x cannot be equal to 0. The denominator cannot be equal to 0. But we're not plugging x values into G. We're plugging f values into G. So we're actually plugging f of x is not allowed to be 0. Because that's what the denominator will become. F of x gets plugged in down here. Which means the square root of 2x minus 6 cannot be 0. And then you solve that out. Square both sides. Add the 6. Oops. And that means x is not allowed to be 3. So we've got two pieces here that we need to combine. X is greater than or equal to 3, and x cannot be equal to 3. Which means when you put those together, you get x is just greater than 3. Greater than or equal to, but not equal to. Just greater than. So that means the domain is just values that are greater than 3. 3 to infinity. Not equal to 3, so it's a parenthesis. So again, for these, you start with the restriction on F because that's where you plug into first. Then you look at G, and you get the restriction on G, but you change X to F of X. So you get your restriction on G, and then you change X to F of X and solve that new equation. Put both of those restrictions together, that's your final domain. All right, here's another one. Start with the restriction on G, because you're plugging into G first. So the radicand, x plus 2, has to be greater than or equal to 0. X has to be greater than or equal to negative 2. And we're going to do the same thing for F. We're going to get the restriction from F. The denominator can't be 0. X cannot be 0. Then we replace X with G of X because we're plugging G into it. So that's square root of X plus 2 cannot be 0. Square both sides. Move the 2 over. And now put our two restrictions together. Greater than or equal to negative 2, but not equal to 2. That means just greater than. So that's from negative 2 to positive infinity. So problems like this, these word problems, break down to, or simplify to be blank varies blank with blank. So that's what we're looking for. We're just looking for those keywords there. You got varies inversely with, and we're just looking to see what the other two things are. What's doing the varying? A varies inversely with square of B. So that's, now we can translate that to math. That's our expression. Now we can translate that to math. Varies means equals k. Inversely means divide. Square of b means b squared. And we're talking about a on the other side. So our equation, a equals k divided by b squared. Plug in what we know. A is 2 when b is 4. 4 squared. So that's 2 equals k over 16. So k equals 32. So now k equals 32 and b equals 3. We're going to find a. K is 32. B is 3. So it's 32 over 3 squared. 32 over 9. Doesn't reduce. That's your answer. Here's another one. Same basic idea. Blank varies blank with blank. So it varies directly with x. And, nope, not that kind of and though. That's it. And y is 30. So directly is x. Varies means equals k. Directly means multiplied by x. Y equals kx. Y is 30 when x is 5. That means k is 6. Find y when k is 6 and x is negative 2. So y is 6 times negative 2, negative 12. Using these graphs to answer the questions, f times g of negative 2. That means we want both values at negative 2. At negative 2, we get a value of 4 for f. And we get a value of 1 for g. F times g, so we multiply 4 times 1, you get 4. F of g of 3 means you plug 3 into g. Plug in 3, you get this point right here, which is 3. And now we plug that answer into f. So now we're plugging that answer, 3, into f. You plug 3 into f, you get 1. Range. Remember, range is the minimum value to the maximum value, the lowest to the highest. The lowest it goes is a negative 3 with a bracket. The highest it goes is up here at 8 with a bracket. The maximum value, we just identified it. It was 8. And it happens when x is 5. The maximum value is 8 when x equals 5. Identify the interval for which it's increasing. Identify your turning points and draw straight lines through it. You got a turning point right there. That's the only one. So if you identify your turning points and your endpoints, you can identify increasing, decreasing. It's decreasing here and increasing between these two lines. So it's increasing from negative 2 to 5. And it's decreasing from negative 4 to negative 2. The input that yields the minimum value is right here. That input is negative 2. The maximum value we said earlier was 8, and we said that that happens when x was 5. That's your input.